Welcome everyone to today's session. Today we are going to start with titration of acid and bases, and we are going to start with a strong acid and a strong base. Remember that when we are talking about titration, usually we are having our setup where we are having either the base or the acid in the burette. So assuming this one is the burette, we are having this one in the burette, which it can be a base or it can be an acid. So an acid or a base. And usually this one does not have any concentration. It does not have a known concentration. So the one in the burette is what you are going to use to determine its concentration. So if it's a base, then you are going to do the titration, or you are going to perform the titration to get the concentration of the one in the burette. So if it's an acid or a base, its concentration is unknown. But usually we are also having something that we are titrating it into, which is more like a conical flux. So with this conical flux, there's a solution inside, and this solution contains what? A standard solution. It's a standard solution because it's having its concentration being known and also its volume as well. So the volume / the concentration is known. So known volume and known concentration. So in a titration experiment, you are going to have one in the beaker or one in the conical flux and the other one in the burette. So the one in the burette is usually the one with the unknown concentration, and is the one that we are going to use its volume to determine the concentration of the one in the burette. So as you are starting with, this time we are doing titration of acid and bases, where we are determining the pH at a particular point when some amount of, let's say, a solution from the burette is being added to the conical flux. So let's begin. Using a strong acid and a strong base, you can even write the reaction down that HCl plus your NaOH, it will give you a salt, which is NaCl plus your H2O. Remember, we've done hydrolysis, and you know that if you're having something which is NaCl, NaCl is a salt that is formed from a strong base and a strong acid. For that matter, it cannot hydrolyze water to make the solution either acidic or basic. So you are going to emphasize on only the excess moles that will be left in the solution to calculate its pH. Here there is nothing like buffer solution because nothing is weak here. All of them are strong acid and strong bases. So let's begin. Before I begin with what I'm supposed to do, let me write the question down so that you all pay attention to how the question will appear. The question will come in the form that we are having a standard solution. A standard solution means it is having a volume and having a concentration, and the one in the volumetric flux, or the one in the conical flux, or the one in the volumetric flux, it does not actually change its volume. Its volume is constant. So the only thing that to be adding up is the solution from the burette, and the solution from the burette, when being added up to the conical flux, the volume of this conical flux, or the volume of the solution in the conical flux, is going to increase. So in our calculation, remember that the more we are adding solution from the burette to the conical flux, we are going to have an increase in the volume. For instance, if you are having 10 ml, of the solution in the conical flux, and now you've added about 5 ml from the burette into the conical flux, remember that the volume of this is going to increase. Even though there's going to be a reaction, the volume of the solution in the conical flux, this is the conical flux, the volume of solution in the conical flux is going to increase from 10 ml to the 10 plus 5 ml, which will give you 15 ml. So always keep in mind that when you are finding the concentration, the formula for concentration is the number of moles over volume. This time around is the total volume. Total volume because you've added some amount of solution also to the conical flux, increasing its volume, and for that matter, it will affect its concentration. So if you don't have a vivid idea about this is the time for you to pay attention to it. Now I'm come to write the question down. Let's all pay attention and follow suit. Alright, so this is the question. The question says that an HCl solution has a concentration of 0.01 molar and a volume of 60 centimeter cube in a conical flux. It is being titrated against potassium hydroxide, which is also a strong acid of the same concentration, 0.01 molar. So this is the follow-up question. Find the pH when 0 ml of the KOH is being added to the solution. The second one is 15, third one 30, and 60 and 70. Remember that when you are seeing 0 ml also represents before the titration was proceeded. Before the titration proceeded, you are not having any KOH. So there will not be. So the pH will actually depend only on the concentration of the HCl that you are having in the conical flask. So before you start with this question, you have to write your equation down. So I'm cleaning it. So first you need to write your equation or your reaction equation. You are reacting HCl with KOH. So what you are expecting at the end is what? A salt, which is KCl plus H2O. Now before the reaction began, they are asking you to find the pH of the solution. So A, when 0 ml, so when 0 ml of KOH is being added. Remember that there's a formula that shows, or there's a relation that tells us that moles is equal to concentration times 8 volume. The same thing applies here. When we are having concentration is equal to your moles times your volume, then you can make N the subject by N equal to your C dot V. So N equal to your C dot V also represents the number of moles, or how to find the number of moles. So it's not always that finding the number of moles, you have to be given the mass. You can also use your concentration times your volume also to determine it. Now let's proceed. To find the pH, we first need to know the concentration of the HCl, and they've given the concentration of the HCl to be 0.01. So our pH will be equal to, so for the first one, our solution, our pH will be equal to negative logarithm of 0.01 molar, which will give us 2. So now the titration process has begun, where the second one, it is requesting you to find the pH when 15 ml of the KOH has been added to the solution. So now let's try and start with the 15 ml. So 15 ml is the same as 15 centimeter cube. So 15 centimeter cube. And if you want to convert it into decimeter cube, you divide it by 1000. You are going to get 0.015 dm cube. Why are you doing this conversion? You are doing this conversion because you want to determine the number of moles. And to determine the number of moles, your volume is supposed to be in decimeter cube. And now they give you the concentration of the KOH. The KOH is also 0. So times 0.01 molar. Then from there, we can find the number of moles of your KOH. So the number of moles of your KOH will be 0.00015 moles. Now, we also find the moles of the HCl. The moles of the HCl is also giving us 0.060 decimeter cube times the 0.01 molar, giving you 0.0006 moles. So now that we are having the moles, remember that it's from the moles that we can determine the pH. Now, looking at HCl and NO and KOH, this one is for HCl and this one for KOH. The number of moles aren't the same. And look at the reaction. They are all reacting in 1:1 mole ratio. So if they are reacting at 1:1 mole ratio, this means that if this is supposed to be 1 mole, then 1 mole of this will be reacting with 1 mole of this to give you 1 mole of KCl and also 1 mole of H2O. So now that we are having a difference in the number of moles, then this means that one will be excess and the other one will be limiting. The one that will be limiting is the one that is having a lesser amount of moles, and the one that is in excess is the one that is having a greater amount of moles. So comparing the amount of moles where we got into right now, at stage B, we are having the limiting reactant to be the KOH because its number of moles is actually a quarter of the HCl. So we find the difference because we know that the HCl is the one in excess. We find the difference in the number of moles, and what you are going to get, we represent it as the moles of the excess HCl left. So as the moles of the excess HCl will be giving us 0.0006 minus 0.00015, and with a calculation you are going to get 0.00045 moles. So this is the moles of our HCl left after the titration reaction, or after you've gotten to 15 centimeter cube of KOH being added to the solution. So now let's move straight into how you are going to find the pH. Finding pH is equal to negative logarithm of the concentration of H plus. So we need to know the amount of H plus. If you're having HCl is also the same thing as H plus and Cl minus. So this means that the moles of this HCl is the same thing as the moles of the H plus. Then we are going to find the concentration of the H plus. So concentration of H plus is given as concentration of H plus is given as 0.00045 moles divided by the total volume. What's the total volume here? When you are having 15 centimeter cube and you've added it to a 60 centimeter cube, combine these two volumes, you are going to get 75, because 60 plus 15 will give you 75. Then 75 centimeter cube, converting it into decimeter cube will give you 0.075. So 0.075 dm cube. Now, with our calculation, you are going to realize that the final concentration of the HCl, or the final concentration of the H plus in the solution, is 0.006. So 0.006. Then we find our pH. Our pH will be equal to negative logarithm of 0.006. Then we use our calculator. So with our calculator, you check it out. Negative log. Let me see whether I can actually compute it here for you. So negative log of 0.006. And you see we're having 2.22. So this 2.22 actually represents the pH after you've added 15 centimeter cubes. So 2.22. So you could see that from our previous calculation, where we've not added anything to the solution, we are having a pH of what? 2. Now the pH is increasing from 2 to 2.22. So what is it trying to imply? What's trying to imply is that you are approaching a neutral region, because you are adding what? Some amount of OH. And this amount of OH is going to react with the H plus from the acid to give you water. The pH of water is actually 7. So the more you continue adding the KOH, a time will be coming where you are going to reach a point you are not going to have any of the HCl or the KOH. You are going to have only KCl and water. And KCl is actually a neutral salt. It's a neutral salt because I've already discussed it with you earlier. And this one too is also neutral. Water is having a neutral pH, or it's having a pH of 7. So it doesn't contribute to any acidity or basicity. So let's try and move to the next step, where we've added 30 centimeter cube of the KAOH, and let's see whether the base will rise or it will still remain the same. Now let's look at the next part of the titration, where we've added 30 centimeter cube of the KOH. 30 centimeter cube is also the same thing as 0.03 decimeter cube. So to find the number of moles of KOH, you have to use the same routine. So the number of moles of the KOH is equal to 0.03 dm cube times your 0.01, which will give you 0.0003 moles. So this is the number of moles of the KOH. Now, we also need to find the number of moles of the HCl. But remember that the one that is in a conical flask is not changing its volume, neither its concentration. So it still remains the same. Then, the number of moles of HCl is still the same thing as 0.0006 moles. Looking at the number of moles of the two things that are reacting, you could still realize that the values are not the same. So there's going to be an excess reactant and there's going to be a limiting reactant. Here, the number of moles of the KOH is still not reaching the number of moles of KCl. So the excess reactant will be still HCl. You have to still be in the acidic region. You don't have to move to the basic region because the moles that will be finishing first is actually what's the base, remaining only the acid. So we find the difference in the number of moles. So difference in the number of moles or the HCl excess is giving us our 0.0006 minus our 0.0003, and it will give us 0.0003 moles. So this is the moles of the excess HCl that will be left. Remember that the moles of the HCl is also the moles of the H plus. So the moles of our H plus is still the same as our 0.0003 moles. So to find the concentration of the H plus, in order to find the pH, we need to divide it by the total volume. If you are having 60 centimeter cube and you add 30 centimeter cube from the burette, you are supposed to get 90. So here we are going to have 0.0003 moles divided by 0.090 decimeter cube. We are having a 0.090 decimeter cube, all from the conversion of 90 centimeter cube to 90 to 0. I mean, you are converting it from centimeter cube to decimeter cube. So if you are having 90 centimeter cube, it's the same to 0.090 decimeter cube. And with our calculation, we are going to get 0.0033. So 0.0033 molar. So this is actually the concentration of the H plus ions. Then our pH is equal to negative logarithm of 0.0033. And we expect our pH to rise. We don't expect the pH to still remain the same. So here, after our calculation, we are realizing that the pH is equal to 2.47. So 2.47. So you see that from 2, we've moved to 2.2 and now we are 2.47. Let's try and do the last but one, which is when 60 centimeter cube of the KOH is added. When you add 60 centimeter cube, now they are having the same concentration, the same volume. So what do you think it will happen? Let's see what will happen at the end of the day. So when 60 centimeter cube of this is added, now we need to find the moles of the KOH. The moles of the KOH is given by the volume, which is 0.060 times its concentration, 0.01, and we expect to get 0.0006 moles. The same thing for HCl. HCl doesn't change its volume, neither its concentration, so it's still 0.0006 moles. Now, from this side, as you can see that you are having a strong acid and a strong base, and they are reacting to give you a salt which does not hydrolyze, which means that if you are having the same amount of the acid and the base and they give you the salt, there is no way this salt is going to play a role in the solution to give you acidic solution or basic solution. Then we say that that salt is a neutral salt. So at the end of the day, if you are forming only a salt without anything in excess or limiting, then you expect the solution to be neutral. This is the concept behind it. But if you want to check out for the calculation too, let's try and look at it. To find the difference in the moles, whether HCl or KOH, whether in excess, we are still going to get 0.0006 minus 0.0006. And it will give us 0 moles. So if you are having a 0 moles divided by the concentration, divided by any concentration at all, or divided by any volume at all, will still not give us a concentration of either H plus or OH minus. All what I'm trying to say is, if you want to find the concentration of HCl or KOH, you are going to get 0 moles divided by the total volume, and the total volume will be 120, so 0.12 anything that is 0 on the numerator divided by any number at all will still give you your 0. So we are having 0 here. So this is that there is nothing in excess or nothing limiting. All what you are having is the salt, NaCl. So NaCl is actually a neutral salt coming from a strong acid and a strong base. For that matter, it's not going to affect the pH of the solution. So the only thing now you have to consider next is water, and water too is also neutral, having a pH of 7. For that matter, the concentration, the pH of the solution when 60 ml. So here we've reached the equivalent point where the stoichiometric amount of moles from the base is also the same thing as the acid. For that matter, they are going to give you nothing left as an excess or limiting. And the only thing that you are having in the solution will be the salt and the water. They are all neutral, so pH is equal to 7. Now let's try and look at the last part of it. When 70 ml of this is being added, or when 70 ml of the base. So when 70 ml of the base is being added to the solution, remember that 70 ml is the same thing as 0.07. So 0.07 times your concentration, 0.01 will give you 0.0007 moles. Now the moles of the HCl doesn't change, so 0.0006 moles. Then we find it. So now looking at the difference, now we are having something, they are not the same. We are having the base rather to be in excess as compared to the HCl. So we find the difference in it. And we having KOH in excess, we have to reach a basic region. We don't have to still be at 7. So we need to bypass 7. Now, our KOH, which is the excess, will be given as 0.0007 minus 0.0006 moles. And what will be left as the moles of the KOH is 0.0001 moles. So this is the moles of the KOH that will be added. Now if you're having KOH is the same thing as K plus and OH minus. Because they are all in a ratio of 1:1, this means that the moles of the OH minus is also 0.0001 moles. Now we need to find the concentration of the OH minus. So OH minus will be given as 0.0001 mole divided by the total volume. So the total volume here we are having 70 plus 60, which is more like 130 centimeter cube. Converting it into decimeter cube will give you 0.13. So 0.13 decimeter cube. And using our calculator, we are going to get 7.69 times 10 to the power negative 4. So 7.69 times 10 to the power negative 4, which is the same as 0.000769. Then you find the pH. Here, before you find the pH, you need to find pOH because you are having the concentration of the OH minus. So pOH will be given as negative logarithm of 0.000769. And you'll be getting our pOH to be given as 3.114. So this is our pOH. How do you find pH? There's a relation between pH and pOH, which is given as pH plus pOH is equal to 14. Because we know our pOH, then our pH will be equal to 14 minus 3.114. And we expect it to be in the basic region. So we are having our pH to be equal to 10.886. So this is our final answer, and you know that we solved this systematically to arrive at this answer. So if you're not understanding anything, I urge you to go back to this video, re-watch it again, and you are going to understand things very